Okay, I think I might be live at this point. Wow, so this is going to be an interesting one. Yeah, so you might notice that my setup is a little different tonight, and you might notice that the quality of the connection might not be as great as one might normally expect from me. And the reason for that is that I'm a little behind on paying my internet bill right now. So I am just tethering off of my phone. And I'm hoping that we can do a little super chat magic tonight to help me out with that internet bill. So I've set a goal for the super chats tonight of 10 super chats, and if we make it, I'm going to go ahead and do a second live stream this month on the topic of y'all's choice. So do please help me out there, and yeah, we'll go ahead and dig in. It is Pi Day, of course, which is a day that is near and dear to my heart. I love Pi Day. Normally, I celebrate it by buying a pie and going out to whatchamajiggets, by going out to DuPont Circle here in DC and giving away free pie to people. But it's a little cold today, number one, and number two, I figured a better use of our time might be to answer some questions and talk a little bit about poi and maybe a little bit about poi math and how math intersects with poi, because this is a thing that I've actually taught about at a bunch of different festivals. It's a topic that is near and dear to my heart and one that I really enjoy. Also, please chime off in the chat and just let me know that you can hear me out there, because on occasion I do not connect the pieces together properly. So if you can do me a solid there, that'd be super helpful. Chime off in that chat, friends. Pretty please. I'd appreciate it. Yeah. I think I've got audio coming through. Do please let me know if I'm accurate in that regard. Okay, Dizzy can hear me loud and clear. Thank goodness. All right then, friends. So a lecture on the topic of poi math. So I don't think that it is a stretch to say that when we play around with poi, we're playing around with circles and circular movements, right? Whether they be things like flowers or weaves or what have you. So let me just talk a little bit about the math that underpins this all, because it turns out it's pretty cool. So when we just spin a poi around in a circle, we can kind of think of this as being on a graph with my hand at the center of the graph with like a y-axis and an x-axis that go through it. And when we do that, we can think of every time the poi crosses the bottom of the y-axis, that is when it goes right here, as being a moment when we're having a downbeat and we're completing a circle. And what's interesting is that we can play around with some variations on this. A lot of people have talked about the fact that when we spin like anti-spin flowers, for example, if you count every time that poi head spins underneath my hand as I go around in a circle here, there will be 1, 2, 3 points. 1, 2, 3 points. This is despite the fact that the flower has 4 petals to it. because we're talking about two different ways of graphing a pattern here. One of these is, of course, the y-axis and the x-axis that we were talking about originally. But the other one is imagining that we're starting from a center point and we're kind of radiating out, and we have specific angles that we are radiating out at. This is what's referred to as polar math. That is, essentially it's like we're looking at the globe from the North Pole, and we're seeing it kind of expand outward along lines of latitude and longitude. So if we think of this in terms of polar math, yes, there are indeed 4 petals to it. But if we think about it with that y-axis and that x-axis, that is Cartesian coordinates, then we think of this as being a 1, 2, 3 petal, or rather 3 downbeat poetric right here. 1, 2, 3, 1, 2, 3. And this pattern kind of gets, oh goodness, we got our first super chat of the night. Huzzah! Poi friends, thank you for everything you do. Thank you, Poi friends. I really appreciate you. Thank you so much. Yeah, welcome this evening. If you have, I'm going to be doing Q&A here as well. So if you have any questions for me, do please let me know. And yeah, enjoy the show. Otherwise, thank you for the super chat. I really appreciate it. Like I said at the jump, the reason my setup is a little weird tonight is that I'm a little behind on paying my bills, and internet is one of them. So right now I'm tethering off my phone and I'm having to use like a really minimal setup. So that $5 is going to go to help me pay off those outstanding bills. So thank you very, very, very much. I appreciate you so much. Cool. So to every anti-spin, there is also an in-spin. And this is a 2-petal in-spin flower. But what's really fascinating about it is, once again, it's only 2 petals if we look at it in polar math. That is, if we start from this origin point and we kind of radiate out and we see where different objects are located around that center point. If we think of it in terms of those Cartesian coordinates, that is those moments when the poi spins down underneath our hand, we wind up with 1, 2, 3. 1, 2, 3 downbeats. And this is something that really trips people up when they're first learning flowers, regardless of how many petals they're doing on their in-spin flowers. So like, actually let me switch to LED poi. That will focus our attention a little bit more on the tips of these patterns here, and I think that will be helpful for our purposes today. Cool. So when we're doing a 2-petal in-spin flower here, we are doing 1, 2, 3 beats, 1, 2, 3 beats. And that's going to be true regardless of where the petals are, because as so many people who've tried sticking the petals top and bottom can attest, there's this very mysterious process here wherein essentially we think that we're doing 2 petals, but it winds up being, we wind up hiding an extra beat on the bottom. Because when we first arrive, there's a beat, and when we complete the petal, there's another beat. So we wind up with 1, 2, 3, 1, 2, 3, 1, 2, 3, with 2 of those beats stacked right next to each other as we enter and exit the petal. Of course, this is really apparent when we start playing around with a 4-petal in-spin flower, in which case we get 1, 2, 3, 4, 5 down beats for these 4 petals. And this winds up having some pretty important ramifications, both in terms of the learning process of how do we get these flowers down, because again, there's an extra beat that in our mind shouldn't be there. But also too, if we're used to just keeping the poi spinning, we wind up in a place where the kind of rhythm of this pattern just doesn't feel right to us. And a lot of people like try and compensate for that by just adding more petals in, trying to figure out where the missing beat happens to be. Which, you're not crazy, it's just we're changing the way that we think about the math of these flowers here. So this is also true of, and going back to our anti-spin flower example here, if we say drop down to 3 petals, then we have a total of 1, 2 downbeats. 1, 2, 1, 2, with that top petal not actually being a downbeat at all. It's an upbeat. And if we turn this upside down, it gets real interesting, because now the 2 downbeats are at the tip of the bottom petal, and as we're taking the poi across between 2 petals. Alien John would refer to these 2 regions as being loops and arcs. That is, whenever you're at the tip of a flower petal, this is a loop, and whenever you're in that broader curve between flower petals, he refers to it as an arc. And this is true whether we are working with anti-spin flowers or whether we are working with in-spin flowers. We still have our arcs and our loops in in-spin flowers, as well as arcs, we have our loops and our arcs in anti-spin flowers. So the long and short of this is flowers kind of break our brains just a little bit, because they require us to essentially convert between 2 different types of mathematics in order to really understand what's going on there. And don't get me wrong, it is 100% legit to think of a 4-petal anti-spin as being a 3-beat pattern, just as it's totally legit to think of a 2-petal in-spin as being a 3-beat pattern. And it's also legit to think of this as being 4 petals and this as being 2 petals. All of these things are true at the same time, and it's kind of annoying. So the formula, when you want to get the breakdown of the number of petals versus downbeats that you have in an anti-spin flower, is that the number of beats is always going to be the number of petals minus 1 in an anti-spin flower, and it's going to be the opposite in in-spin flowers, where you get the number of beats is equal to the number of petals plus 1, which makes sense if you stop to think about it. Because essentially when you do an in-spin flower, you are kind of nestling a smaller circle inside of a bigger circle. So if you want to think of beats as being the completion of a circle, then there are really 3 circles inside of a 2-petal in-spin flower. There's the big one and the 2 little ones. So 3 downbeats makes sense. I wish there was as easy a trick to use with that on the anti-spin flowers, but alas. So what does all this have to do with pi? Well, one of the ways that we can graph these poi patterns is through the use of what are called parametric equations. Essentially, we can take a graph that includes both x and y terms and use that to basically, with a graphing calculator, graph out all these different shapes that we create when we're spinning poi. And I will go ahead and include a link to an old blog post I did on all of this in the chat for anybody who is intrigued to learn more. And also, do please send in those do please send in more of those questions, friends, because I'm happy to answer them today. Or I can just keep going off about poi math. I'm certainly happy to do that. I am totally down with either option. But yeah, let me pull up my old blog. All right, enjoy, friends. That is the first blog entry that I did on Poi math, and that will guide you through some of the basic concepts here, including parametric equations and periodic math. And I think there's also a link in here to a paper that I wrote on the topic. Oh, actually, I don't see the link to the paper. No, it is in there. Never mind. Cool, cool. So, enjoy that paper, dear friends. Enjoy that paper. Awesome sauce. So, that's a little bit about the math of poi flowers and flower petals. So, for anybody who wants to hear it, I will keep waxing on about math unless y'all have some questions for me. Chime off in the chat if you do. All right, so next math story. So there's this old math problem that is called the 7 Bridges of Königsberg. Königsberg is a city, well, it's now called Kaliningrad. It's in that weird little enclave of Russia that's like stacked between, Estonia, Latvia, and Lithuania. It's that weird little like island of Russia that's on the other side of, oh, somebody chimed off in the chat. Jillian says, hey there, Jillian. Just to catch you up, Jillian, we're talking about poi math this evening, and also doing a little bit of a fundraiser here because I'm a little bit behind on my bills. So if you have the means, a super chat would be appreciated, and I will happily both bump your question up in the queue, as well as we are shooting for 10 super chats in the course of this hour, and if we get to send to 10 super chats, I will go ahead and do a second live stream this month. So we have that to look forward to. Anyway, yes, the 7 Bridges of Königsberg. Königsberg being modern-day Kaliningrad. So there's an island that's in the center of a river that goes through Kaliningrad, what was then Königsberg. And there's this, actually, I will draw it out for you because it'll be a lot easier to understand then. Surge1226 says thanks. Sure, you're welcome. Welcome. Good to have you. All right. And the real question, do I have a working marker that I can use for this? All right, so we're going to get a little nerdy tonight, friends. We're going to get a little nerdy. All right, so this is my incredible drawing of the river that passes through Königsberg. It has 2 islands on it. A big island and a small island. Now, what's interesting about this is the big island, hang on, I think, yes, I think this is right. I think this is right. Fingers crossed. All right. So these lines here represent bridges that passed between the islands and the mainland on either bank here, right? And so for centuries, there was this math problem going around about the 7 Bridges of Königsberg. Namely, is it possible to go through Königsberg and cross each bridge only once? No backtracking, no double tracking down the bridges. This was an open question for something like 300 or 400 years, and many, many, many mathematicians tried and failed to solve it. And then along comes a guy by the name of Leonhard Euler, who finally finds a solution to this problem, and in the process gives birth to several branches of mathematics. So our dear friend Leonhard Euler recognized something really interesting about this problem. Namely, that he could essentially abstract the whole problem down to this. So to guide you through Euler's thinking here, we've got the North Shore, we've got the South Shore, we've got the West Island, which has 5 bridges connected to it, and we've got the East Island, which has 3 bridges connected to it, right? So Euler's first insight was to just say that he could just think of each landmass not as like a massive landmass in and of itself, but just as a dot. He basically kind of crushed each landmass down to just a single point, and then he connected those points together with lines that were meant to represent the bridges, right? So you can think of this as being basically a diagram that abstracts down those 7 bridges of Königsberg into something that's a little bit more manageable. And once Euler did this, he really quickly realized that there was no solution to the 7 bridges of Königsberg problem. Here's why. Whenever you have one of these points, which are now referred to as vertices, if you have a bridge that carries you into that point, if you're going to exit back out of it, you need a second bridge to take you back out, right? Which means that if you're going to go through each bridge only once, there needs to be an even number of bridges connected to each of these points, because you need one to take you in and one to take you out. There's only one exception to that, and that exception is if you have one point that is your beginning point and one point that is your end point. Those are the only 2 points that can have an odd number of points attached to them. So if we take this diagram that Euler came up with, we can see there are 3 bridges connecting together the East Island. There are, oh, this is so hard to do mirrored. 1, 2, 3, 4, 5 bridges connected to the West Island. There are 3 bridges connected to the North Island, and there are 3 bridges connected to the South Island. So that means there is absolutely no way to travel around Königsberg going over each bridge only once. It is physically impossible. But we can create a variation on this. We can add some additional bridges, and that will make it possible to get through this. He refers to it as a graph. So to do this, I'm going to add some additional bridges, including ones that are not possible in real life, but you'll see why I'm doing this in just a second. So in addition to a bridge connecting the North and South Island, I'm also, the West and East Island, I'm also going to create a bridge that connects together the North and the South Island. In addition, I'm going to go ahead and actually, screw it. I'm just going to go where I'm going here so that you can understand what I'm getting at. So I've added a whole bunch of bridges to this, and may not look like it, but I've just created a pattern that I think you all actually know. Let me show you. So we can start on that north shore and go over to the east island and then to the west island, and then we can go back up to the north island, straight down to the south island, back over to the west island, back over to the east island, down to the south island, and return to the north shore. Sorry, that wasn't a south island, that was a south shore. So again, our pattern here is from the north, we go east, west, north, south, west, east, south, north. Hey, check it out. You know what that is? That's Zan's diamond. Zan's diamond is a solution to the 7 bridges of Königsberg problem, if we could add a couple extra bridges in there. So the term for one of those graphs that you can go over and hit every bridge only once, the term for it is a planar graph. That is a graph that can be flattened down to a single plane. And wouldn't you just know it, Zan's diamond is also a planar graph. So we have the 4 points of Zan's diamond, just like we do with the 7 bridges of Königsberg. And if we create the bridges properly going through Zan's diamond, guess what? We can create a pattern that is easily repeatable and where we go through each transit only once. Pretty cool, huh? Pretty cool. Dizzy is losing her mind right now. Outstanding, outstanding. I love blowing minds. Oh, and Jillian has a question. How do you put math to gunslinger flowers, and how do you do gunslinger flowers? Oh, 2 excellent questions. So let's tackle them one by one, shall we? So first up, how we do, and also just to put it out there, that solution to this problem, realizing that if you want to have a graph like this, that you cross each transit only once, each bridge only once, having this knowledge that you need at least 2 bridges connected to each point is actually, you're going to find that that problem is something that comes up in some rather unexpected places in life. So hold on to that one. Put that one in your back pocket, because you never know when it'll come in handy. There are actually a lot of brain puzzles that pop up on Facebook every so often that turn out to be graph theory puzzles. So keep an eye out for those, because now you know how to find the solution. Okay, so let's talk gunslingers for a second here. Cool, there we go. All right, so gunslingers. Interesting poi tricks that essentially transform a single poi into a meteor. You hold the middle, or in the case of contact poi, you hold the tether about like 1/3 of the way from the head, and you're able to spin the poi like a very, very short meteor and a very, very rapid meteor. So how does the math around flowers and petals work for these for gunslingers? Because and just to start, well, let's establish a couple things right quick. Number one, kind of the basic thing you do with a poi when it's in a gunslinger is a thumb-led 2-beat weave here. Actually, let me pull out another poi here so I can give you some details with things a bit longer. Good enough. All right, so white poi is going to be my thumb end. Purple poi is going to be my pinky end. So notice, actually, let me make that color a little bit more different because purple might not register on camera for y'all. I'm going to take that around to red because that will be a big contrast. Come on. There we go. Okay, cool. So red is my pinky end and white is my thumb end. Now, as I'm going back and forth here, I hope you can see, I hope it's slow enough with me just, with me doing this meteor style, that my thumb end is always leading as I go back and forth here. This is a 2-beat weave here. It is the equivalent of this right here, if say I was always like having my left hand lead through a 2-beat weave with both hands. It doesn't look asymmetrical because it's all coming out of the one hand. And of course, I have a 2-beat weave going reverse over here on the other side of my body. This is a reverse pinky lead weave. You can see I have the red poi leading now, and it's the equivalent of doing this right here where I'm always having my left hand lead, yeah? Cool. So we can go back and forth between these two weaves. I can do a 4-beat weave on my right, I can do a 4-beat weave on my left, like so. Now the thing is, I can do this exact same thing with gunslingers. I can do my, you know what? I can make the handle red so this is more obvious. Yay, modes. Whoops. The only downside of this is if I miss the mode, I have to cycle through all of them again. Please hold. There we go. Okay, so I am doing my 2-beat thumb lead weave over here on my right, and then I switch to my 2-beat pinky lead weave over on the left. Exactly the same as I'm doing here. Whoop. Sorry, I'm trying to avoid hitting the television. Don't need to add that to the bill at this point. So, 2-beat pinky lead, 2-beat thumb lead. This is identical. 2-beat thumb lead, 2-beat pinky lead. The only thing that's different is I'm just using a single poi instead of both poi as I'm going back and forth here, yeah? Okay, so we got 2 beats on either side if we just go straight back and forth like this. This is a 4-beat waist strap. We could actually do 3-beat weaves on each side. I don't think they look particularly good because even though they're switching off which end is leading, it looks kind of weird and asymmetrical when we're doing it with just one hand here. So I prefer to just keep it as a 2-beat weave personally, but 3-beat weave is also an option. So 2-beat thumb lead, 2-beat pinky lead, we can go back and forth between them. And as you can do with any kind of waist strap, you can take one end and make it go up and the other end and make it go down. That is, as you're going back and forth between those two positions, one will go up, one will go down as you go around here. And this turns it into a flower. All waist straps, when you add that up and down motion to them, become flowers. So we can do this with gunslingers, and that creates both in-spin and anti-spin flowers for us here. So if we just keep track of the thumb end in these flowers, we know that we have 2 beats on one side and we have 2 beats on the other side. And when we do anti-spin then, we are performing a total of 4 beats, of course. And if we go back to the equation that I gave us earlier on in the live stream, because with anti-spin, the number of beats is the number of pedals minus 1. We can also reverse that equation and say that whatever the number of beats is, the number of pedals is going to be beats plus 1. So if I have 4 beats total here, then my thumb end is getting in 5 anti-spin pedals. And we can kind of see that there because we got the top pedal and then one near my left shoulder, one near my right shoulder, and one near each of my hips. 1, 2, 3. It happens very quick. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 as we go around here, yeah? And of course, when we go to in spin, the opposite holds true. We're dealing with 4 beats once again. I hate doing the in-spin version. Oh, it's so ungainly. When we work with 4 beats here, we wind up in a position where we have 3 in-spin pedals. Now, here's the part that'll mess with, well, there are 2 parts that'll mess with you. The first one is that I'm only counting the number of pedals that I'm getting out of my thumb end and all of that. There's also a pinky end to worry about as we go through here. So the pinky end is doing, if I'm doing anti-spin, it's doing its own series of 5 pedals. And guess what? Those 5 pedals are located in different places than the 5 pedals that the thumb end is doing. So I would refer to that 4-beat fountain that we turn into a flower with our gunslingers as being a 10-pedal anti-spin flower, a 10-pedal gunslinger flower rather. So this is a 10-pedal, and we can also take just a 2-beat weave and turn that into a flower by moving it around in a circle. And essentially what this turns into is you wind up with 2 triquetras that are kind of out of phase with each other. It looks a little bit like a Star of David maybe. So the 4-beat fountain gives us a 10-pedal anti-spin flower, and the 2-beat weave gives us a 6-pedal anti-spin flower. So here's the next part. This will be the part that really breaks your brain, is that these are functional equivalents to patterns that involve just a single or 2 poi. So like, if I'm doing this 6-pedal gunslinger flower, do you see how I'm just moving my hand around a pretty small area here? That area matches up with the distance covered by an isolation. So remember that the gunslinger is getting me in 2 beats, as I'm going back and forth over here. 2 beats equals 6 pedals for a gunslinger. The equivalent, if I let the poi out to full length, is a cat eye. This is a single beat move. It's a single beat anti-spin, and how many pedals this thing has is a matter of some debate. But we'll just say for right now that this is a single beat anti-spin. And so when I switch that up to a 2-beat anti-spin, because I've made the poi half as long, so now it takes twice as many beats to get through this pattern. I've now created 6 pedals. Each end is creating 3 pedals for a total of 6. So a 6-pedal gunslinger is the equivalent of a we'll call it a 2-beat gunslinger. A 2-beat gunslinger is the equivalent of a 1-beat poi move at full length. And likewise, when we have our 10-pedal gunslinger here, remember, this is based on having 4 beats. And the functional equivalent of this, when we go to full length with the poi, halves the number of beats because it is when we use a longer poi, it's traveling half as fast. And this results in a triquetra. So I can do triquetra versus static spin, or I can do a 10-pedal gunslinger versus a static spin. They are functionally interchangeable. So the key with gunslinger flowers is to realize that you're basically creating functional equivalents to normal poi flowers, but you're doubling the number of downbeats, and you're also doubling the number of petals because you have two ends to work with. So it gets confusing really quickly. But the thing to keep in mind is that every gunslinger flower does have an equivalent with regular poi grips. You just have to figure out which one it's going to be based upon the number of downbeats. That was a very long answer to that question. I hope you all followed me through that. Jillian says, I am so wanting to actually practice the 2-beat weave with one hand now on both sides of the body. Love how this becomes a flower and looks so simple but complicated at the same time. Yep, you know, you're not wrong there. You are absolutely not wrong. Gunslingers are really fun because they throw so many of the rules behind how we think poi is supposed to work out the window. But at the same time, also, Surge1226 says, thanks for the explanation. You're so welcome. You're so welcome. Yeah, it's a trip, right? It's a trip. Cool. Well, we've made one of our goal of 10 super chats here. So the struggle, says Dizzy. Yeah, you're not wrong. We've got like another 20 minutes to get those super chats in there, friends. So don't be shy about that, and also don't be shy about asking questions here, because I got poi math coming out my ears, and I'm happy to explain anything that I can. I should also take this opportunity to hydrate because I have been talking a blue streak. By the way, if any of you all want to learn more about Leonhard Euler and how he came up with the solution to the 7 bridges of Königsberg problem, and more specifically, how the many branches of mathematics that came out of his solution to the 7 bridges of Königsberg problem, or his discovering that there wasn't a solution to it. There's a phenomenal book I would recommend. It's called Euler's Gem, and Euler is spelt E-U-L-E-R because the dude is Prussian, and of course nothing is pronounced the way it seems like it should, at least to me. So Euler's Gem is the name of the book. You read that, not only will you learn about the thought process behind his finally proving that there was no solution to the 7 bridges of Königsberg problem, you also discover things like why the fact that we live on a globe means that hurricanes happen. It is actually a direct consequence of the shape of our planet, and there's no way around it, which is kind of cool. And also, too, why if you have a ball covered in hair, like a kiwi or something like that, you will inevitably wind up with a cowlick at some point on it. It's actually the exact same reason that we get hurricanes. It's fascinating. I highly recommend this book. Surge1226 says, love to hear you discuss the geometry involved. I'm glad to hear that. I'm glad to hear that. I do enjoy talking about my mathematics. It's true. Yeah, any other questions out there, friends? Keep them coming, please. I'm trying to think if there are any other fun geometry things I can throw at you. I mean, there are tons of fun geometry things that I can throw at you, but it's a question of, well, actually, so here's one that, like, I never hear people discuss this, and I personally think this is one of the coolest things that Cyril, the French poi spinner who essentially created the contact poi boom in the early 2010s. This was something that came out of an earlier work of his that I think is that I absolutely adore this. So whenever we're spinning our poi in together same, there's this really fascinating thing that happens, which is that it looks like we're producing two copies of the same shape that are kind of, it's like doubling. It's like you're seeing double here. You're cross-eyed, or you've had a bit too much to drink, or what have you, and you wind up with two copies of the same image just sitting next to each other. If we do the same thing in together opposites, yes, we still have those two shapes that are right next to each other, but the funky thing that happens here is that they seem to reflect across a line that goes straight down our middle. That is, they reflect across a center axis of symmetry. And if we take those same patterns and perform them in split time opposites, we wind up in a position where the symmetry goes across a horizontal line. That is, whenever we are spinning our poi and creating our patterns, they seem to reflect across a line that's even with our shoulders. In the same way that this reflects across our center line, almost like we've stuck a mirror on it, this makes it so the poi pattern seems to reflect across a mirror that we put at our shoulder level, which is a different kind of symmetry than the human body has. And I think this is one of the reasons why split time opposites winds up being one of the more challenging timing and direction modes to get down. So, obvious question then, what about split time same direction? So there's two ways that you can look at this. One is that the axis of symmetry is constantly changing. Basically, it's moving around with us as we move our hands around. The other way you can look at it is that rather than having a vertical line or a horizontal line that we're reflecting across, it collapses them both down to just a single point that's like kind of dead center. And we're always creating patterns that reflect across opposite ends of that point. So you can find this in a paper that Cyril wrote, good Lord, 15, 16 years ago, called Poi Spinning in Geometry. And it has some really cool ideas in it, including what, if I'm not mistaken, is the first, dark light, this is four-pedal anti-spin timing and direction variations. Yes. Specifically talking about the geometry of them and how they reflect, which was a fabulous discovery that, what is this? Oh, gotcha. This is a fabulous discovery that Cyril made. Okay, so Drex has a tech poi math paper. Yes, Drex does. That is accurate. Yeah, Jillian, while spinning poi, how do you put this math formula into use with the poi? A1x plus B1y plus C1 equals 0 and A2x plus B2y equals C2 equals 0. I don't know. I don't recognize the variables that are in use there. I don't know where you got those from. So without some kind of context around that, I don't really know what they're describing, unfortunately. But yeah, I was just discussing how Cyril framed the geometry of spinning poi according to the four timing and direction modes, which, like, I personally think that looking at them as different modes of symmetry is fascinating, and it creates interesting uses for each one of them too. Yeah. So, who else we got out there with questions? Lay them on me, friends. Lay them on me. Awesome, says Surge1226. Yay. Y'all have me for another 10 minutes here. Throw those questions my way. Throw those questions my way. And hopefully I'll know how to answer them. A1x, B1y. Yeah, the thing I'm most baffled by in the equations that you shared, Jillian, is that A1x plus B1y plus C1 should just, oh. That was weird. So A1x plus B1y plus C1 should just simplify down to A times x plus B times y plus C. The ones aren't really necessary in there. So I don't know why they're there. And again, I'm not sure where those equations came from, so it's hard for me to apply them to poi spinning, unfortunately. But yeah. Other questions, friends? Other questions? Send them my way. Questions about math, questions about poi, questions about pi, questions about the history of math, since I appear to be lecturing on that tonight. Yeah, lay them on me. Lay them on me, please. Shannon Color, just wanted to tell you I especially love your quick beginner tutorials. You are a great teacher. Hi from Ohio. Hello there. Appreciate you. Surge1226 says, I'm a musician, music teacher, intermediate staff spinner, beginner poi spinner. I love how the flow arts tie to Tai Chi and philosophy. Interesting. So, yeah, I mean, I think that, like, you know, clearly the flow arts and geometry, like there's a lot of places where you can connect those dots. You can model a lot of poi patterns using trigonometry and the like. I will definitely say that this is some info about the formula, says Jillian. Okay, cool, can't wait. Oh, weird. Why did that happen? That's so odd. Interesting. Sorry, to find the point of intersection, POI of two lines. Gotcha. Okay, so it's nothing to do with poi spinning. It's point of intersection. That's cute. I like that. I'm still going to say A1x plus B1y plus C1 should just simplify down to AX plus BY plus C. It's weird. I don't know why they put it that way. That's funny. That's funny. Oh, love your connections between math and art, says Surge1226. Thank you. I like them too. Yeah, and again, you can check out that poi math paper I wrote because there are a lot of connections, so many. Michael Zealand, how would you recommend getting into poi? What to watch to hype myself? And Dizzy, want to tell them what you just completed a solid rough draft on? Sure. Yeah, so I have been working on a really super detailed poi beginner course now for 6, maybe 7 years. Those of you who saw my the video series I did during quarantine, the learn how to spin poi during COVID series, that was kind of me working out some of the kinks in it, working through some of the stuff that I had on my outline and testing it out to see how it worked. I also did a series of live stream classes a little over, starting a little over 2 years ago and running for several months. I'm still doing the live stream classes. In fact, if anybody's interested, you can come check out the next one, which is going to be in It's going to be coming up this week. Why didn't that work? That's odd. Here we go. Cool. You should check out my live stream class. Yeah, so I still teach live stream classes, but getting back to it. So that refined the material a little bit more. And now I have a pretty good outline of that beginner course. And I'm hoping that over the course of the next couple months, I can go ahead and actually shoot video of it and have it up on my learning site, have it available for anybody. So yeah, that's how I'd recommend getting into poi. But being as how, that's a little far off in the future. For the time being, I would recommend checking out my Learn to Spin Poi during the COVID-19 quarantine series that I did on YouTube. It is the best free resource that I have available for right now, and there will the course will be available, God, hopefully by the end of the summer. Knock on wood. So that's what I would recommend. Sharon Collier, will you be teaching or performing anywhere East Coast this summer? Have you ever heard of Nelson Ledges Quarry Park in Ohio? No, I have not. I'm not currently booked to perform or teach anywhere. Would you like me to come and teach nearby you? I will confess that I don't normally attend flow festivals anymore, simply because they tend to be a big commitment of time, and I find that I get a better connection with my students when I teach through my own workshop tours, when I travel myself to places and just teach solo. I tend to find that at flow festivals, people are being dragged 11 different ways. They haven't slept all night. They tend not to be very focused. And so the connection I get with my students when I tour and do my own workshops, I find is much better. So if you'd like to see me tour through your area, yeah, let me know. Let me know if that is a thing that you would like to see happen, because I can definitely see a case to be made for it. I haven't toured in a long time now. So Jillian says, I didn't realize the abbreviation was point intersection formula, not poi spinning. I Google it and that's where I got the formula from. Ah, that makes sense. That checks out. Yeah. All right, friends, we got only a few minutes left here. So any last minute questions, throw them my way. Throw them my way. Got 3 minutes here. Type fast. Type fast. Shannon Color asks, Akron has a great flow community. I have places, contact info that I would love to host you. Cool. Email me, drex@drexfactor.com. Tell me a little bit about the venue that you have in mind, and we can see if that's something that's doable. Jillian says, will you be doing any in-person workshops? I don't know. It's a good question. Would you like to see me up in your neck of the woods? Let me know. I'm certainly open to the possibility. Those workshop tours are kind of difficult to schedule, not schedule, but budget out. I will say that I can see a case for coming to Ohio to teach some workshops, because my girlfriend Dizzy lives in Ohio, and it would make an excellent excuse to come out and see her and her little ones, and also, you know, make a little money off of it too. So yeah, I can definitely see a case to be made for that. Also, my brain is just like having a whole thing with the lighting here and like kind of trying to find the angles. But yeah, yeah, I'm definitely open to coming, and Ohio's big enough too that I could see like going around the state, because like I've taught in Cincinnati, I could teach in Columbus, I could teach in Cleveland, Akron, Dayton, and like there's enough distance between all those cities that I think that I could probably teach in multiple cities and not have them overlap too much or cancel each other out. Jillian, I wasn't sure if you would teach a workshop in DC even. I'm open to teaching a workshop in DC for sure. The challenge is always getting people to show up, right? I think there's a little bit more demand for me to teach in places that I don't live. People in DC know that I live here, and so I think I've tried teaching workshops here before, and they tend not to be well attended because people are just like, oh, well, I can just see him in a week or two or what have you, regardless of whether they actually will see me in a week or two. So traveling elsewhere to do workshops usually turns out a little bit better for me, but we'll see. I mean, I have toyed with the idea of hosting my own flow event, something like a festival, but not actually, like not a festival because that's kind of not my jam. Something more like a convention or a dance meet or something like that. And I would like to do that here in DC. I think that would be fun. Not the least of which because I get to introduce people to this city that I live in and that I absolutely adore. Yeah. Poi Friends asks, pie-related question. This will be the last one. What's your favorite? Mine is apple. My favorite pie is pumpkin pie. No Thanksgiving or fall season is complete without pumpkin pie with a whole big mound of whipped cream on it. That's what makes a Drex happy. Great question. All right, friends, we are at the hour. Solid. Cool. I'm glad you liked that answer. We are at the hour, so I'm going to go ahead and shut things down here. Thank you once again so much to Poi Friends for the super chat here tonight. I appreciate you so much. Jillian's squeezing one more in. Have you thought about applying to Transcend Fest in Connecticut? They pay teachers to teach here. I've never heard of it, but I will go ahead and look it up. Thank you all so much for joining me tonight. Have yourselves a good evening, and I guess then I will be seeing you next month. Take care, friends, and hopefully my internet connection will be back up then, and I will not be just tethering off my phone, which is connected to my power cable, so I can't bring it on screen, unfortunately. Thank you all so much for joining me. Take care of each other and yourselves, and have a good night. I appreciate you all. Peace.